Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Hello and welcome to Learning Garage. I'm your host, Gaia Babatunde Lamin, and of course I'm here for the mathematics session. Today, of course, we are going to continue from where we stopped the last time. Remember, we have been speaking about sorts, how we rationalize sorts, how we evaluate sorts, and how we find the conjugates of sorts. And today, of course, I shall be starting from the points that I left. Remember, we had an exercise wherein I told all of us to go and practice, okay? I'm going to, of course, start from there. And then, of course, we are going to introduce another new topic, okay? Which would be indices. But before we go on to indices, I think we need to solve that last problem we solved, at least for the benefit of those who missed our last class, okay? And here the question says you have to simplify. You have to simplify. You have to simplify 2 root 3 minus 6 upon the root of 3 plus 3 upon the root of 27, okay? And this came in June 2010. Yes, this was a past question from June 2010. It says you have to simplify 2 root 3, okay? It's not the square root of 3, it's 2 root 3 minus 6 upon the root of 3 plus 3 upon the root of 27. So this simply gives us what? Sorry. This gives us now we are given a fraction. We are given mixed fraction here, okay? But at the same time there are sorts all over. So how can we get across with this one? Okay, so definitely we are going to treat them as fractions, okay? But alongside we are going to be simplifying, we are going to be making life easy for all of us, okay? Remember we said in fractions, whenever there is a whole number, every whole number is upon 1, okay? It stands as a figure wherein you have that number upon 1 is the same as the number itself. So therefore if you have 2 root 3 is the same as 2 root 3 upon 1, okay? So therefore we can go ahead and find our LCM there. 2 root 3 minus 6 root of 3 plus 3 upon 27 is the same as what? 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. And of course the root of 9 is what? 3. So this will give us what? 3 root 3, okay? So if we find our LCM there, of course this is upon 1. The LCM there would be what? 3 root 3, okay? The LCM there would be 3 root 3, okay? This will give us 3 root 3. So therefore the LCM is 3 root 3, and then we can simplify now. 1 into 3 root 3 is will give us what? 3 root 3 multiplied by 2 root 3. That is to say 2 root 3 multiplied by 3 root 3, okay, minus root 3 into root 3, or 3 root 3 divided by root 3 gives us what? 3, okay, we are in the roots, will cancel out, and then we are left with what? 3. 3 times 6 gives us what? 18, okay, plus 3 root 3 divided by or into 3 root 3 gives us what? 1. So therefore 3 root 3 divided by 3 root 3 gives us 1. 1 times 3 gives us 3, okay. So we'll end up having, now we have 2 multiplied by 3. We are going to multiply what is out of the root and multiply by the number that is out of the root, that is 2 multiplied by 3, which will give us 6, then multiplied by 3 root 3 gives us what? 3. 3 root 3 multiplied by 3 root 3, as we said, again gives us 3. We are not going to waste time over that, okay, minus 18. 18 plus 3 gives us what? Or let's simply represent it in that form again. So this will be minus, okay, I go over this part again. So we are going to, of course, replace or bring down our 18 plus 3, okay, all upon 3 root 3, okay. So this will give us what? 3 times 6, or 6 times 3 gives us 18, would be minus 18, and then our plus 3 all upon 3 root 3, okay. So 18 minus 18 plus 18 minus 18 gives us what? 0. So 0 plus 3 is 3 upon 3 root 3. So far so good. I think we made some progress, and this is not the end of the problem, okay. We have to further simplify. Remember, whenever you are dealing with sorts, you don't leave your final answer as the denominator as your final answer in a sort form, okay. So you have to maybe rationalize or maybe try to simplify as the case might be, okay. Now we are having what? 3 root 3 of, so we are having 3 upon 3 root 3, okay. But remember, 3, this is the same as 3 upon 3 multiplied by 1 upon root 3, okay. 3 upon root 3, 3 upon 3 root 3 is the same as 3 upon 3 multiplied by 1 upon root 3, okay. We are in our 3 and 3 cancels, we are left with 1 upon root 3. This one will give us what? We multiply now by the rational of the denominator. We'll have what? 1 upon root 3 multiplied by numerator 1 multiplied by root 3 all upon 3 roots, all upon root 3 multiplied by root 3. So if we multiply 1 multiplied by root 3 gives us what? Root 3 all upon root 3 multiplied by root 3 gives us 3, okay. So therefore our final answer would be 1/3 root 3, okay. That will give us our final answer. So if you solve the problem, this is our final answer, okay. So this gives us our final answer for the problem, which says 2 root 3 minus 6 upon root 3 plus 3 upon root 27, okay. So I hope we all understand. We're going for a short break, and when we come back, we start up with a new topic. Stay tuned.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcast are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Yes, so welcome back from that short break. We are moving ahead now, okay? We're now going to introduce indices, okay? What are indices? Or what is indices, okay? Indices is a mathematical term that is used to express larger numbers that are always or almost raised to a certain degree, okay? So here in indices we are going to be looking at some of these types of problems, okay? These are some of the things that we are going to encounter, okay? We start with a simple definition: indices and the laws of indices, okay? It says indices are useful ways of more simply expressing large numbers, okay? Well, if you have large numbers, you have to express them in indices form, okay? They also present us with many useful properties for manipulating them using what are called the law of indices, okay? There are certain laws that are put aside that will guide us to understanding our topic better, okay? We start up. What are these laws, okay? We say indices, of course, they can be expressed. For example, you have 2 raised to the power 5. 2 to the power 5 is the same as 2 times 2 times 2 times 2 times 2, okay? 2, you multiply 2 to a 5th degree, then it will give us what? 2 to the power 5, okay? The 2 there is our base, okay? There you see the 2 there is our base, okay? These 2 here represents our base, okay? And of course the 5, which is the index, of course stands for our index, okay? So therefore let's jump straight into the laws. The laws, we start with law number 1, which is, okay, you say to manipulate expressions you can consider using the law of indices or the law of indices, right? I say these laws only apply, okay? These are some of the basics, okay? These laws only apply to expressions with the same base, okay? For example, you have base 3 raised to the power 4 and base, of course, 3 raised to the power 2. Of course, meaning that 3 raised to the power 4 and 3 raised to the power 2 can be manipulated using the law of indices, okay? If you have different base, then the story is different. Like for example, you have 3 raised to the power 5 and you have 5 raised to the power 7. These are different base, okay? They have different base, so therefore we cannot manipulate them in that form, okay? We're going to just simplify them and leave it in the most simple form. Yes, so we are starting up with the first rule of indices, okay? Our first rule here says whenever you have any index, okay, whenever you have any base rather that is raised to the index of 0, okay, the value is always equal to 1, okay? The end result you have what? 1, okay? For example, if you are given 5 raised to the power 0 is the same as 1, 10 raised to the power 0 is the same as 1, 99 raised to the power 0 is the same as 1. Example you're given there, it says you have to simplify 2 to the power 0, okay? Solution, you have to simplify 2 to the power 0. You have 2 to the power 0 here, we says what? It is equal to 1. Another example again, like we said, if you are given 99 raised to the power 0, okay, the law says any number that is raised to the power 0 is equivalent or is equal to what? 1, okay, and so on, okay? That is as simple as that. Move on to the second law. The second rule says what? When you're given a raised to the power minus m is equal to what? 1 upon a to the m. That is to say, when you are given any value which is raised to a negative value or negative sign, as the case may be, okay, it is a reciprocal of that particular value. What do we mean by that? To give an example, you are asked to simplify 2 raised to the power minus 2. Okay, 2 raised to the power minus 2. 2 raised to the power minus 2 is the same as the reciprocal of what? 2. Okay, that is to say 1 upon 2 raised to the power 2. This will give us what? 1 upon 2 times 2, which is equal to what? 1 upon 4. Okay, similarly, so this could be written as also 4 raised to the power minus 1, which in reverse will give us what? 1 upon 4. Okay, and at the same time 1 upon 4 is going to give us what? 4 raised to the power minus 1. Okay, so that is the second law, the rule of the second law. Okay, second law again says when you are given any value which is raised to a negative value, okay, that is to say when the base is raised to an index which is negative, therefore that result of that particular indices will result to be a reciprocal of that particular base. Okay, that is to say if you are given a raised to the power minus m, okay, the resulting value would be the reciprocal of a raised to the power minus m. Okay, that will give us 1 upon a raised to the power m. Okay, our third rule there says what? If you are given a raised to the power m multiplied by a to the power n is the same as what? Whenever the base are the same, of course, what we have to do if there is a multiplication sign in between the two indices, therefore we are going to add their powers. Okay, that is to say you take a representation of the base which is a raised to the power m plus what? N. Okay, even if you have p raised to the power q multiplied by p raised to the power b, this will give us what? P raised to the power q plus b. Okay, now let's take this example. The example says what? You have to simplify. Okay, solution, you're asked to simplify here 5 multiplied by 5 raised to the power 3. Okay, 5 multiplied by 5 raised to the power 3. Okay, we are given 5 raised to the power 5 multiplied by 5 raised to the power 3. This will give us what? Again, whenever a number stands alone, it is always equal to what? We say but our 5 there, but our 5 there is equal to what? 5 raised to the power 1. Okay, which is the same as 5. Okay, if you are given a raised to the power 1, it is the same as a. You're given b raised to the power 1 is the same as b. So therefore, if you are given to solve 5 multiplied by 5 raised to the power 3, this is equal to what? 5 raised to the power 1 multiplied by 5 raised to the power 3. Okay, this resulting multiplication gives us what? 5 raised to the power 1 plus 3. Okay, so therefore we add the index there. If we add the index, we'll have what? 5 raised to the power 1 plus 3 gives us what? 4. The next rule there says if you are given a raised to the power m, if you are given a raised to the power n divided by a raised to the power n, this will be the same as what? When there is a division sign, you subtract the powers. Okay, whenever you're given an indices of the form of this nature, okay, if of course our base are alike, meaning they are the same, so what do? We take the form of the base and then we add, and then we subtract their powers. We subtract the powers, meaning it will be m minus what? N. Okay, similarly again, if you have b raised to the power l divided by b raised to the power m, this will give us what? B raised to the power l minus m. Okay, so there is a situation here which says you have to solve, you have to simplify 5 solution, you have to simplify 5 multiplied by y to the power 9 divided by y to the power 5, or y to the 5. Okay, this will result in giving us what? Of course, we maintain our 5, which is out of the bracket, and then of course, according to BODMAS, whenever you have a relationship like this, you have to consider what is inside the bracket first. Okay, so to simplify what is in the bracket, it says what? Y to the power 9 divided by y to the power 5. Okay, the law says when the base are the same, we take the base, and then what do we do with the powers? We subtract the powers, which is 9 minus 5. Okay, subtracting the powers. Okay, this is all in brackets, so this will give us 5 multiplied by 9 to the 5. 9 minus 5 gives us what? Y to the power 4. Okay, so this will give us, now we can then multiply 5 multiplied by y to the power 4, which will give us 5y to the 4. Okay, I hope we all understand, and these are the basics of forming, or what forms, or what brings about solving situations in indices. Okay, we now move on to our next rule. Rule number 5 says what? When you have a situation which says when you have a bracket of a to the m multiplied by n is the same as what? You are going to multiply what is in the bracket, the power that is in the bracket, to the power that is out of the bracket. That is to say, m multiplied by n. This will give us what? A to the power mn. Okay, similarly again, if you are giving b to the power q, okay, all raised to the power r is the same as what? B to the power q multiplied by the power r, which will give us b raised to the power q r. Okay, now let's look at an example. It says square all raised to the power 6. Okay, you have to simplify y square all to the power 6. Our solution there comes about, say y raised to the power 2 all to the power 6. This is the same as y raised to the power 2. We have to clear the brackets. We have to multiply the index, which is 2, multiplied by the other index, which is 6. Okay, 2 times 6. This will give us y raised to the power 2 times 6, which will give us what? 12. Okay, 2 times 6 gives us 12, or 6 times 2 is the same. Okay, regardless of the position. Okay, now we move on to our next law. The next law says, or rule number 6 says, whenever you have, okay, you have an indices or a base that is raised to an index which is in the form of a division, okay, or in division form, you can express that one also in short form, or in that rational term. Okay, or how would I say, in radical terms. You can express that one in radical term, meaning that if we are given here a, you are given a raised to the power m all divided by n, and of course by virtue of what the law says, you have to what? Represent this in the form of a short form, or in a radical form, meaning you have to imply the square root sign there. It will be a, the root of what? The nth root of a, okay, all raised to the power m. Okay, that is to say, a raised to the power m under the nth root. Okay, which is also equal to, equivalent to, the nth root of a, okay, all raised to the power m. Okay, you can factorize the power. Okay, you can factorize the power of the numerator of the index, okay, to be that factor that will multiply what is of the radical sign there. Okay, let's take example of what we are saying. Example here says you have to simplify 125 to the power 2 upon 3. Okay, remember we said we are starting from a simple problem to a more or bigger problems, okay, or more complex problems. Now we are given the number 125 raised to the power 2 upon 3. Okay, And to simplify there, 125 raised to the power 2 upon 3. Okay, because solution. So 125 there could be represented as what? 5 times 5 times 5. Okay, all raised to the power 2 upon 3. But 5 times 5 times 5, which is 125. 5 times 5 is 25, multiplied again by 5 gives us 125. Could be written as 5 raised to the power 3, all raised to the power 2 upon 3. Okay, this will result in giving us what? 5 raised to the power 3 multiplied. When you are removing the bracket there, you introduce the multiplication sign, which says what? 3 multiplied by what? 2 upon 3. Okay, and of course 3 multiplied by 2, of course 2 upon 3 is in the form of a fraction. So being that you have a separate denominator and a separate denominator on either side, so this gives us the power to what? To nullify. Okay, you can say 3 is common here and 3 is common here, so you are left with what? Or 3 and 3 cancels, because if we again say 3 multiplied by 2, which will give us 6, all upon what? 3 is the same as, can 3 enter into 6? Yes. How many times? 2 times. Okay, so it is the same as 5 raised to the power 2. 5 raised to the power 2 is the same as what? 5 times 5. 5 by 5 gives us what? 25. Okay, so 25 will be a final answer, or you can leave it in the form of indices. Okay, which will be 5 raised to the power 2. You are still correct. If you say 25 again, you are still correct. So far so good. Those are all the basic laws, and I hope we understand what we are saying. Okay, please remember always, okay, you have to simplify to the lowest degree. You have to simplify to the lowest degree. We're going to take a short break. When we come back, Learning Garage continues. Stay with us. Welcome back. Of course, this is Learning Garage. I'm your host, Gaiga Babatunde Lamin. Of course, we are discussing, or we are treating indices. Okay, we are treating the basic rules of indices, how we can go about solving problems using these basic principles. Okay, remember, mathematics is all about the foundation. Okay, if the foundation is not there, it will be difficult for us to understand and learn better, of course, any bigger topic or any complex topic in mathematics. You cannot enter into trigonometry without understanding indices. You cannot enter into anything like calculus or anything like something that is harder, okay, without knowing or getting a broad understanding of indices. So we are going to take a few examples. We are going to take as many examples as possible so that we can understand. From there we solve past questions. Okay, our first example here says what? Simplify minus 2x to the power 0. You have to simplify minus 2x to the power 0. Okay, solution, we said minus 2x raised to the power 0 would be equal to what? We said any index, or any base which is raised to the power 0 is equal to what? 1. Okay, we say where x raised to the power 0 is equal to 1. Therefore, this implies that we have minus 2x raised to the power 0 would be equal to what? 2 multiplied by what? 1, which is the same as 2. Okay, anything that is raised to the power 0 is 1. Example 2. The next example says we have to simplify 6 multiplied by y raised to the power 4, all raised to the power 5, all upon 12y to the power 4, y to the power 5. Okay, so I think this one is beautiful. It says you have to simplify 6 multiplied by what is inside the bracket, all raised to the power 5, and of course our denominator there is 12y to the power 4 multiplied by, of course, y to the power 5. reading 12y to the power 4 y to the power 5. Okay, so our solution there would be what is inside the bracket you tend to expand, okay, or you tend to, that affects our power there would be 6 multiplied by y to the power 4 multiplied by 5, okay, all upon 12y to the power 4 y to the power 5. Okay, this will give us 6y to the power 4 times 5 gives us 20, all upon 12y to the power 4 and then our y to the power 5. Okay, so can we simplify this one further? Okay, again remember, for our denominator we have y to the power 4 and y to the power 4 there. Okay, this will result in giving us 6y to the 20 all upon 12y. Remember there is multiplication sign between the two y's, so therefore this will be y to the power 4 multiplied by y to the power 5, which will give us 6y to the power 20 upon 12 y to the power 4. If there is multiplication in between, what do? We add the powers. Okay, 4 plus 5. Okay, this will give us 6y to the 20 all upon 12y to the power 9. Okay, so simplifying further, this will give us 6 upon 12 multiplied by y to this 20 all upon y to the 9. Okay, by separation of powers it will be the same. Okay, this is just a form of you separating the actual natural numbers from the index there, okay, or the rational values of the y terms there. Okay, so therefore this will give us 6 upon 12 would be 1 upon 2, that is 6 into itself is 1 into 12 is 2 times. Okay, multiplied by, of course there is 9 there, 9, that is to say 9 of 9. Okay, I would put it, you say, for example, if you have 12 mangoes, okay, you asked to reduce 9 mangoes from those mangoes, what would be the remaining there? So if we divide y to the 20 divided by y to the 9, this will give us y to the 11. Okay, y to the 11, and of course this will give us we can still represent it as y to the 11 upon 2, or we leave it as half y to the 11. Okay, whichever will give us the correct answer. So this is Learning Garage. We are learning gradually. Okay, remember we started with simple laws. Okay, those laws could be confused for bigger problems. Okay, we move on to the second another problem. You're asked to simplify 5 multiplied by what is inside the bracket there, which is 8 x to the power 4 divided by 2 multiplied by x raised to the power 2, or 2x to the power 6. Okay, you have to multiply, you have to simplify what is inside the bracket, which is 5 multiplied by 8x to the power 4 divided by 2x to the power 6. Okay, this will give us what? We are firstly going to simplify what is represented, or what is being represented in our bracket there. What is inside the bracket, according to board math, it says 8 to the power, or 8 multiplied by x to the power 4, okay, divided by this man. Okay, so this will result in giving us now 8 is the same as 2 raised to the power 4. 2 times 2, 4 times 2, 8. Okay, 2 raised to the power. So 8 again is the same as 2 raised to the power 3. Okay, multiplied there by our x to the power 4, all divided by what? Our 2 to the power x, 2x to the power 6. Okay, so I can still represent this man as what? My 2 to the power 3 x to the power 4 all upon 2 multiplied by x to the power 6. Okay, this will give us 5 into, and of course there, if we divide there, we'll end up having 2 square. Okay, because 2 here can enter. Remember, this is 1, it is 2 raised to the power 1, and of course if we reduce one index, if you reduce a single index from 2 to the power 3, you are left with what? 2 square. Okay, so this 2 square will be multiplied by what? And of course if we again divide what is on top compared to what is underneath, you will end up having what? 2 square upon x to the power 2. Okay, that is to say, this will give us what? 5 multiplied by 4 upon x square. Okay, this will end up giving us what? 20 upon x square. Okay, so this will give us our final answer. So therefore, this Learning Garage, we're going for a short break. When we come back, we shall continue. Stay with us.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Welcome back. This is Learning Garage, which is coming to you live from Star TV, and of course we are talking about indices. Remember, we are talking about the laws of indices. These laws are what are the fundamentals of what you solving problems or you treating anything that is related to indices. Okay, another example there, we move on. It says what you have to simplify 5a upon b square all raised to the power 2. Okay, you have to simplify 5a upon b square, okay, all raised to the power 2. For every step you take in these indices, of course, for every step you take, you are relating in your mind, okay, the laws or the rules that have been given. Okay, therefore this one says what? 5a upon b square is the same as what? 5. Okay, this is the same as what? We apply distributive law there. It says what? 5a all square all upon b square all raised to the power 2. Okay, this one will give us what? 5 square multiplied by a square all upon what? B square multiplied by, of course, 2. This will give us what? 5 square, which is 25, a square all upon b raised to the power 4. Okay, since these two are not of the same base, Okay, that is to say our a is never or not equal to b. Therefore, there is no way you can simplify a okay, and b. Okay, there is no way. So therefore, the final answer, you leave it like that, which says 25a squared upon 4 upon b raised to the power 4. Okay, our next example says we have to simplify 3a raised to the power minus 2. Again, we said any value which is raised to the power minus 2 would be what? The reciprocal of that value. Okay, that is to say this will be 1 upon 3a all square. Okay, this will give us what? 1 upon 3 square multiplied by a square. Okay, this will give us what? 1 upon 9, which is 3 times 3 gives us 9, multiplied by our a square, which is the same as 1 upon 9a square. Okay, this could be also represented as what? Or can be also, of course, this is our final answer. Again, the reverse of this would be what? 9a raised to the power what? Minus 2. Okay, or for simplicity, another example again says what? You have to simplify our value there, which says 2 upon r square all raised to the power minus 3. Okay, we apply the distributive law there, which says 2 raised to the power minus 3 all upon r to the power 2 all raised to the power 3. Okay, and of course we treat the numerator separately, and of course if we are treating the numerator separately, this implies that this will have 2 raised to the power minus 3 divided by what? R square all multiplied by 3. This will give us what? 2 raised to the power minus 3 divided by what? R to the power what? R to the power 2 times 3. Okay, which will give us 2 raised to the power, or it is the same as what? 1 upon 2 raised to the power 3. Okay, divided by what? R raised to the power 6. Solving this further, okay, we'll end up having what? 1 upon 2 raised to the power 3 multiplied by the reciprocal of that one. Now we are changing the sign from division to multiplication. We'll end up having 1 upon r to the 6. This will give us what? 1 by 1, or 1 times 1 gives us 1 upon 2 to the power 3 multiplied by r to the power 6. This will end up giving us 1 upon 2 to the power 3 r to the power 6. Okay, so this will give us our final value for the problem there. Okay, another example says you have to simplify 3y squared t to the power 2 divided by 3y t squared all raised to the power minus 2. Okay, so therefore in solving this will give us what? We apply the law of distribution there. This will be 3 square y to the what? 2 times 2 again, all multiplied by t square divided by, this acts as a single unit, divided by our guy there, which says 3 raised to the power minus 2 multiplied by y raised to the power minus 2 multiplied by t square all multiplied by what? Minus 2 all, yes, okay, all results to that one. In solving this further, making life better for us, now we are going to what? Have 3 square y to the 4 t square, okay, divided by 3 raised to the power minus 2 multiplied by y raised to the power minus 2 multiplied again by t raised to the power minus 4. Okay, so now if we make this neater again, this will be 3, I bring down our values again, okay, divided by 3 raised to the power minus 2y minus 2 raised to the power minus 2 multiplied by t raised to the power minus 4. Okay, by way of division between the two. Okay, we say when the bases are the same, what do we do with the powers? Okay, we subtract their powers. Okay, that is to say you have 3, okay, raised to the power 2 minus 2. Okay, then you have y is multiplied by what? Y raised to the power what? 4. If you are taking y and y, then therefore what do you do with the powers? You subtract again into minus 2. Okay, multiplied by t square minus into minus 4. Okay, remember there is a minus there, so if you are introducing another minus, you have to introduce a bracket. Okay, so this will give us now 3 raised to the power 2 minus 2 gives us what? 0, multiplied by y to the power what? Minus times minus gives us plus, which is 4 plus 2, multiplied by t raised to the power 2 minus times minus gives us plus, multiplied of course plus 4. Okay, maybe this will end up giving us 3. We say any number raised to the power 0 is the same as what? 1, multiplied by y raised to the power 4 plus 2 is 6, multiplied by t to the power 2 plus 4 again is 6. So finally we end up having 1 multiplied by anything is the number itself. Okay, so you are going to have y to the power 6, t to the power 6. Okay, so this will give us our final value, which is y to the power 6, t to the power 6. So now let's look at another problem. The problem here, by the looks of it, it might be complex but simple. Okay, this one says you have to simplify 3 m to the 8 n to the 3 all divided by 3m to the 8 n to the 3 all raised to the power 0. Okay, remember we say but a raised to the power 0 is the same as 1. So if you have a unit in that bracket, therefore this will be what? Raised to the power 0, which will give us what? 1. Okay, so solution there will have what? 3m to the power 8 n to the power 3 divided by what? 3m to the 8 multiplied by n to the 3 all raised to the power 0 is the same as 1. So therefore this will be what? 3m to the power 8 n to the power 3 divided by 1 is the same as what? 3m to the power 8 n to the power 3, which will be our final answer. Another example there says what? You have to simplify 32 x to the power 10 all on upon y to the power 5, okay, all raised to the power 3 upon 5. This will give us, okay, we distribute again the powers for both numerator and denominator. We'll have what? 32x, okay, to the power 10 all raised to the power 3 upon 5 all upon y to the 5 all raised to the power 3 upon 5. Okay, this will give us what? 32 will be reduced again to the power, say 2 times 2 4 times 2 8 times 2 16 times 2 gives us 32. That is 2 raised to the power 5. Okay, 2 raised to the power 5 x to the power 10 all raised to the power 3 upon 5. Okay, divided by what? Y to the power 5. Okay, of course multiplied again by 3 upon 5. Okay, if we reduce the bracket, or if we remove the bracket rather, this will give us what? Okay, we're distributing there the powers. This will give us 2 raised to the power 5, okay, all raised to the power 3 upon 5, okay, multiplied by x to the power 10 all raised to the power 3 upon 5 divided by our y there, which says 5 multiplied by 3 upon 5. Okay, this will give us what? 2 raised to the power 5 times 3 upon 5 multiplied by x raised to the power 10 multiplied by 3 upon 5. So this will be all divided by y to the power 5 multiplied by 3 upon 5. Now if we simplify this one, our 5 there goes with this 5, our 5 here is 1, our 5 here is 2. Okay, this 5 and 5 cancels out, so you end up having 2 raised to the power 3 multiplied by x raised to the power 2 times 3, which is 6, all upon our y there raised to the power 3. So this will finally give us what? 2 raised to the power 3 x to the power 6 upon y to the power 3. Okay, this will be our final answer. This will be our final example for today. We are asked to solve or simplify. We are asked to simplify. Okay, our 27a to the 9 all upon 125 raised to the power 3, which is b cubed, all raised to the power 2 upon 3. Okay, again, according to our laws of indices, this will end up giving us what? If we end up distributing this one out, okay, we'll end up having, that is 27 raised to the power 2 upon 3 multiplied by a raised to the power 9 all raised to the power 2 upon 3, all upon our 125 all raised to the power 2 upon 3 multiplied by b cubed all raised to the power 2 upon 3. Okay, simplifying this again will give us what? 27 is represented as 3 times 3 times 3, which is 3 times 3, 9 times 3 gives us 27. So this is 3 raised to the power 3 all raised to the power 2 upon 3 multiplied there by what? Our a raised to the power 9, okay, all raised to the power 2 upon 3. Okay, this is upon our 125 there is 5 times 5, 25 times 5 gives us what? 125. That is to say 5 raised to the power 3 all multiplied by 2 upon 3 multiplied by b raised to the power 3 times 2 upon 3. So this gives us what? Our 3 here cancels this 3, so it gives us 3 raised to the power 2 multiplied by 3 here is 1, 3 into 9 gives us what? 2. 2 times 3, or this is, that is to say 3 times 3 is 9. Okay, so we have a raised to the power 2 all raised to the power 2 all upon, and 3 and 3 cancel, so you end up having 5 raised to the power 2 multiplied by, and 3 is common here and 3 is common here, so you end up having b raised to the power 2. Okay, this will end up giving us what? 3 raised to the power 2 a raised to the power 4 all upon, that is 2 times 2 gives us 4, and then you have 5 square is the same as 25 b square. Okay, this will give us our final answer. So this brings us to the end of our session today. Of course, we have been talking about indices, where we spoke about the laws which governs indices, how we can simplify anything that comes our way. Okay, so therefore I want to say thank you very much for paying attention, being with us. I'll encourage you to call up your friends and see how we can practice together, see how we can challenge more problems, and of course in our next class we are going to solve past problems which have been coming in the WAS exams. So being your host, Gaira Babatunde Lamin, I want to say thank you, and please stay tuned to Star Television. Bye bye.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction.